Hey guys. So yeah, I'm Dan. So yeah, over the last few weeks I've been fiddling around with Rails 5 and ActionCable, and I'd like to share with you how that went. So first of all, some of you guys might be wondering what is ActionCable. Basically, it's WebSockets for Rails. It was introduced in Rails 5, so it's a relatively new feature. So the whole idea of ActionCable is you can implement real-time communication between the server and the client. So not HTTP requests, it's backwards and forwards. And how it works is it introduces this concept of a channel and connections. So your client will create a WebSocket connection with your Rails server, and then you define a channel, which is kind of like a controller for a WebSocket, and then the clients can subscribe to a channel and publish messages to it, and that's how the communication works. And yeah, that works off good old-fashioned Rails black magic. We'll see some of that just now. This is a basic diagram. Excuse my paint drawing there. I used GIMP. So you have your regular Rails app over there, and you define yourself a channel. Clients perform actions, like controller actions, to the channel, and then the channel can then broadcast messages to each client. And that just happens constantly backwards and forwards over the WebSocket. There are many applications for this. Namely, the most common one is a chat app. You can then implement notifications in your app. User posted a new comment. You can do live updates or real-time charts or live maps. It's basically endless. Even this presentation is built using ActionCable. As our first little mini demo experiment here, I'd like you all to go to this URL on your laptop or phone. Fingers crossed. Oh, there we go. So you should be able to see the same slide that I have on the screen. So let's see if that works. Yeah? Did it work? Okay, cool. So basically, this is how it works. In the channel, I define an action for next slide. I then go find the presentation, update the slide number, render the slide view, which this is a cool thing in Rails 5. You can render views outside of your controller. I think they actually added that so that you can render views inside your channels, especially for this kind of thing. And then you just broadcast the new slide with the new HTML to all the other clients. And then on the JavaScript side, it works just the same. You create a subscription, define the next slide, which just performs the next slide action, and on received data, you can then just do your logic, insert the HTML, do some animations, and then on a key press, on my side here, I perform the next slide action. And then obviously with some authentication, otherwise you guys are going to be like fucking around with my slides right now. So yeah, I mean, that's all there is to it. It's really straightforward. It just works. Yeah. Now, on to the next part of my talk, which is developing multiplayer games. And then later we'll bring these two concepts together. First of all, the anatomy of an actual game is pretty straightforward. There's something called a game loop. It works kind of like this. My paint skills. You have your player, and then you have your game. They provide input to the game. It runs a constant loop, and it displays the result to the user, or the player. And that's how it works. And in that loop, there's physics, game logic, etc., happening all the time. Then when it gets to multiplayer games, then it starts getting a lot more complicated. Because now, you've got to synchronize that game logic across everyone. They've got to see the same thing. And you've got like ping and all this kind of nonsense going on. So it gets pretty crazy. Some of the early multiplayer games use something called peer-to-peer deterministic lockstep, which is quite a mouthful. So basically, this is how it works. So you've got each of these little guys playing their games, and this is the peer-to-peer, each person connects to every other player. And when a user sends an action, like I click this guy, click him there, it sends that action to everyone else, and then all the other people receive all the actions for that step in the game loop and perform the same logic. So it's synchronized, it's peer-to-peer, it's deterministic. If you receive an action, everyone should execute it in the same way. And it's called lockstep because each of those players have to run the game loop at the same time. Which means that if one guy is like in freaking Southeast Asia and his ping is like 5,000, everyone's ping is 5,000. Mostly strategy games like Age of Empires use this sort of thing. The next thing which came out was client server, which is obviously something that's a bit more familiar to the rest of us. And it basically works like this. So you've got your little players going on there, and they connect to a server. They send the server the actions, and the server runs a game loop and sends the resulting state back. This works much better for first-person shooters and stuff like that because your ping only affects you. And also another thing is that you can drop in and out of a game like whenever you want. With deterministic lockstep, everyone has to synchronize at the beginning. So yeah, those are the two main multiplayer game strategies, I guess. So yeah, with server client, you send input, you receive state. The important thing is that the server is law. The server is authoritative, so that prevents hacking and cheating, so you can't say, hey, I'm actually over there now. The server will be like, you're there. And then you teleport back. And then you also have to deal with some lag because if you say, I'm moving that way, and the server's like, oh, he's moving that way, and I tell him, okay, you're over there now, and then you like press W, and then 5 seconds later you finally start moving. So that's when you start having to do client-side prediction. So that's why in the diagram, each of the little games have their own loop as well. If you press forward, you want to feel immediate reaction. So you start moving, and then you send this action to the server, and then the server eventually comes back and says, yes, you're over there. And then locally you have to like match it up, how different are they? And that's why when you like have lag, you like start this rubber banding thing, like you run and then you like jump back, and then you fly into the moon or something like that. Yeah, and then there's a whole world of complicated shit here because there's like network physics as well. I won't get into that, it's too much. Yeah, so on. Okay, so multiplayer game programming is hard. I'm only just getting into it, and shit's crazy, man. So yeah, let's see how we're going to put this all together. So there's some easy pickings, first of all. It's Rails, guys. There's all the black magic. Super easy setup. Rails new. Added a channel, started getting right into it. Channels and broadcasting, get that for free. Authentication with device even, like you can just current user in your channel. There's a little bit of setup, but it's not really that bad. And yeah, everything seems to be going well, and then the problems start. There were quite a few of them, actually. First of all, Ruby just isn't made for this. Like, last year I demoed that Mitsu game engine that I made, and like, maths on Ruby, difficult stuff. Running game loops on Ruby, difficult stuff. Yeah, so, yeah, you can't just run a game loop on a Rails server. I tried. Shit broke, man. And it gets clogged up with players very, very quickly. Like, I demoed it at the Global Game Jam recently, and we had like 20 people join while I was busy building it, and my laptop nearly went full Galaxy Note 7 on me. So yeah, I had to figure out how I'm actually going to build a game. I discovered Action Cable is actually pretty shit, performance-wise, that is. I mean, it's a fantastic thing, but just letting you know that don't think it's going to be all, well, yeah. Well, that's not the end, right? Okay, well, I'm still going to do this. I'm determined. First of all, the one thing I realized I had to do was delegate it to the client. So the server is just like a go-between. So the clients actually run all the game loops. So now there's a bit of a problem there because the server is not as authoritative because now the client is running the logic. But there's a few ways you can get around that. So it's kind of like a mishmash between server, client, and deterministic lockstep because you've got the clients are sending actions to each other, but there's still a server involved. So here's my shitty paint drawing again. So it's very similar to the client-server architecture, except your actions and state are going like both ways. So the client's going to say, I'm here and I'm moving there. And then the server will say, okay, guys, this guy's here and he's moving there. Okay, so I also had to kind of find a game type that I could build that doesn't have as much traffic, because sending messages like constantly. So FPS and racing games out of the question, because like you move and every game tick you got to say I'm moving forward, I'm moving forward, I'm moving forward. Hey server, did you know what? I'm moving forward. I'm shooting that guy now. It's too much for Rails. So I thought maybe like a turn-based strategy, but I thought you could build a turn-based strategy with HTTP. So what's the big deal? I eventually settled on a MOBA, like League of Legends, Dota, Heroes of the Storm. Another thing that I realized is a problem with making a game in Rails is you can't really do database transactions in your channel actions because this thing's got to be like fast. And your database is like on the other side of town in terms of the latency. So you can't be like, okay, cool, this player is moving, let me get the player, let me update his state, let me get all the other players and tell them that this player's state's updated, and then do that like 50 times a second. It will kill you. And then the last thing I stumbled upon is something called AnyCable, and this is quite interesting. It's a drop-in replacement for ActionCable that is implemented in, there's an implementation in Go, there's an implementation in Erlang, excuse me, which dramatically speeds up ActionCable. Like it lowers the memory usage and the latency, so that's kind of like solves your scaling problems. So yeah, so maybe it's not so shit after all. Now for our big reveal. Okay. So I'm going to, oh snap, I need to run the server, don't I? Should have set this up beforehand. Okay. Hopefully, if you guys are on the Wi-Fi, you'll be able to actually connect to it, but let's just... Oh my word, is that my IP address? Let me just show you the show it to you first. Right. Okay. Fingers crossed, fingers crossed. Whoa. My bad. Obviously don't have that, resilience everyone's been talking about. Okay. Really? Oh, there we go. Okay, cool. So this is devise in action. Oh, really? What did I do? Oh, right. Wrong password. Beware the demo gods, they will strike. Okay, I'm also going to do the magic part here and okay. So on this side, it's really hard doing this with one hand. test 2. Okay, so let's create a new game. Let's call it Fuza 17. Create. Up. So many things. I need that dev up thing, eh? I have another branch where I have a proc file. I could have just used that. Okay, now this is going to actually screw up, so I'm going to have to make another one. Again. Okay. Yes! Okay, so this is what my game looks like. I'm terrible at modeling and animation, so you are a cube. And this is on the other side. So it's classic red versus blue. I copied the Dota map, roughly. And you just kind of click around. You can throw grenades and missiles. Cheers, missile. And drum roll, please, because eventually this map is fucking huge. I am playing a multiplayer game. How's that? Oh, there, the missile blew up. So now everything works there. You can shoot homing missiles by clicking on people if you don't like them, and throw grenades at them, and shoot rockets at them. And I missed. Oh, he's dead. There we go. And you got a kill cam as well. So like there he's going like, haha, I'm gonna destroy a monument there. Yeah, yeah. How do you like that? Missiles. You got the health bar going on, and then you're like, hey, dude, leave my shit alone, man. Just. Like the cooldowns on these things are like super low because I was like debugging. I didn't have time to balance it out. But yeah, there it is. Don't know if you guys want to actually try and join this, see if we can blow up my computer. So where's that IF config? Hopefully, is it EN0? Is it this one? 172.16.4.68. Oh, there's the sign-ins. Okay, you guys don't have to use your real email addresses or anything like that. I don't have like mailers or anything. Hey? Oh, port 3000, you know, the default one. Okay, so I'll just let you guys sign up, and then you can join the Fuza 17 again. Don't join the other one because Redis wasn't running, so it didn't create it. So you will have monuments with 0 HP. Fun times. Ooh, hey, there he is. So it's starting to lag a bit now, but hopefully it'll stick together. I've tried reducing the dependencies on the database, but there's still a few database calls still in there, so damn it, Kevin! Oh shit, yep, it's happening. Rubber banding. Everyone is conglomerating behind the red monument. I cannot move, but yeah. This is why, think again if you want to make a multiplayer game with Rails, because this shit happens. I can't even fire missiles, like how ridiculous is that? Come on. Wow, I've never had so many people fry an egg on this thing. Whew. Okay, so enough DDoSing for one day. Cool, so let's get back to the slides quick. So I just like a special thanks to Platform 45 for sponsoring my trip out here. And this is the cool part about these sharing slides thing. You can click on that to go to our website. Yeah, and you can get in touch. There's my GitHub and Twitter. They're also clickable. Cool.